In today's class, we will study about the various applications of electrolysis. The first application of electrolysis is electrolytic refining. What is electrolytic refining? As the name is implying, it is the refining or the purification of a given impure metal by the process of electrolysis. So in a nutshell, you can call it as electrolytic refining. Here we are taking an example of how this electrolytic refining can be done of impure copper slabs. So here we have taken an electrolytic cell in which these thin strips of pure copper and the thicker slabs of impure copper are being used. These thin pure copper strips are attached to the cathode, so they are acting as cathode, and the impure copper is acting as the anode since attached to the positive terminal. This is done with an AD. Since the cations that will be produced from the impure copper slabs will deposit at the pure copper strips, therefore the pure copper strips already existing are attached to the cathode. So let's have a look at the electrolyte that we will be using here. The electrolyte is aqueous copper sulfate and dilute sulfuric acid. The question is why we have added the dilute sulfuric acid to this aqueous copper sulfate. This is simply to increase the conductivity of the ions. Because the H2SO4 are going to increase the number of the ions. देखो, aqueous copper sulfate. The aqueous copper sulfate has got H2O, then it has got CuSO4 and then H2SO4. कौन से ions होंगे? H2 will give us H positive and OH negative. Fine. CuSO4 will give us Cu2 positive and SO4 2 negative. And what will H2SO4 give us? It will give us H positive and SO4 2 negative. So it is going to produce this ion and this ion, right? No new ion is produced, and this sulfate ion and this sulfate ion. So the total number of ions are getting increased, and therefore obviously the conductivity will increase. So now let us discuss about how the impure copper slabs gets purified. The impure copper slabs are being attached to the anode. So obviously what will happen at the anode? The reaction at anode, since impure copper slabs are acting as the active electrode. Active electrode means they are going to produce their own cations. So what will they do? The copper will produce the copper cations, right? Obviously these copper cations are of pure copper. We know the three steps. These copper ions will migrate, discharge and deposit at cathode. Now what will happen at cathode? The cathode is a pure strip of copper. Now the question is कि हमने pure strip of copper को cathode क्यों बनाया? देखिए, what are we trying to do? हम impure copper को purify करने की कोशिश कर रहे हैं so that in the end of this electrolytic refining हमें pure copper ही मिले. तो उसके लिए हम क्या चाहते हैं कि हमारा जो कैथोड है जिसके ऊपर ये कैटायंस जाकर डिपॉजिट होंगे वो ऑलरेडी प्योर कॉपर का होना चाहिए. अगर वो किसी और मटेरियल का होगा तो उसके ऊपर इन एनी केस कॉपर कैटायंस जाकर डिपॉजिट होंगे और एज अ रिजल्ट ना जो एंड प्रोडक्ट हमें मिलेगा वो दोबारा से इम्प्योर ही मिलेगा, क्योंकि ऊपर कोटिंग तो प्योर कॉपर की होगी, लेकिन अंदर क्योंकि हमने कैथोड किसी और मटेरियल का बनाया था, तो ऑब्वियसली एट द एंड हमें इम्प्योर कॉपर ही मिलेगा। ऐसे में हमें करना क्या है, हम कैथोड को प्योर कॉपर का ही बनाएंगे ताकि जितना भी डिपोजिशन हो वो प्योर कॉपर की स्ट्रिप के ऊपर फर्दर मोर कोटिंग के साथ हो। सो कैथोड के ऊपर क्या रिएक्शन रहेगा, the copper cations, here we have the copper cations, so the copper cations will migrate, discharge and will deposit at cathode as copper. So simple reactions hai. So after some time, what will you observe when these two reactions will be over? What will be the observation? थोड़ी देर के बाद we will see that gradually the cathode, what is cathode here? The cathode is pure copper strips. इसमें एक word और use कर देते हैं, thin pure copper strips. These pure copper strips which were thin will gradually become thick. They will increase in the mass. They will gradually become thick, right? And the impure copper slabs will become thin. Why? Because their copper will migrate towards these प्योर कॉपर स्ट्रिप्स। तो ऑब्वियस है कि प्योर कॉपर स्ट्रिप्स का मास इंक्रीज करेगा तो थिक हो जाएगी, और जो आपकी इम्प्योर कॉपर स्लैब्स हैं क्योंकि उसमें से कॉपर माइग्रेट कर रहा है, उसमें से कॉपर निकल रहा है, सो दे विल कीप ऑन बिकमिंग थिनर इन मास। During the process, one more observations will be there, that is the collection of this anode mud below every anode. यहाँ पर देखो, ये जितने भी आपके impure copper slabs हैं, इन सब के नीचे anode mud collect हो रहा है। Now, what is anode mud? Anode mud is basically the impurities which are present in these impure copper slabs. कौन से metals की impurities थी? ये थी गोल्ड की और सिल्वर की। जनरली गोल्ड और सिल्वर की इम्प्योरिटीज होती हैं हमारे इम्प्योर कॉपर स्लैब में। तो होगा क्या, इस एनोड मड को बाद में कलेक्ट करके फर्दर और रिफाइनिंग हो जाएगी, बट हमारा जो कॉपर है इसमें से माइग्रेट होगा, जो हमारा एनोड है इसमें से कॉपर माइग्रेट होगा इन द फॉर्म ऑफ कैटायंस, बिकॉज एनोड इज एक्टिव इलेक्ट्रोड and since it is active, it will produce the cations. These cations migrate towards the cathode, and cathode they will migrate, they will discharge, and then they will deposit, and that is how the electrolytic refining of copper is all done. Now let us talk of the second application of the electrolysis. The first one is the electrolytic refining, and the second one is electroplating. Electroplating. Electroplating is one of the most important application of electrolysis. What is electroplating? Basically, electroplating, the word is a fusion between two different words, electro and plating. Plating here is indicating the coating, that a coat has been made on a cheaper metal, generally a cheaper metal, with a more expensive metal by passing the electricity, that is by the process of electrolysis. So generally we can say electroplating is a process in which one metal is coated on the other metal by the process of electrolysis, and it is known as electroplating. Generally electroplating is done in order to protect a metal from corrosion. For example, iron is protected by the electroplating of another metal, for example nickel on it, so that no corrosion is there. Then sometimes the electroplating is also done to give a better look to the object which is to be decorated, generally used for the decoration purposes, and Even the galvanization is also classified as a part of electroplating. Now, what are the different conditions which are required for electroplating? The first condition is that the article which is to be electroplated that must be kept at the cathode. देखो ध्यान ये रखना है कि हम आर्टिकल को, जो भी आर्टिकल है, वो एक स्पून हो सकती है, वो आपकी की हो सकती है, वो कुछ भी हो सकता है, जिस भी आर्टिकल के ऊपर आप दूसरे मेटल की कोटिंग चाह रहे हैं. मेटल की कोटिंग मतलब मेटल को आप कोट करना चाह रहे हैं. मेटल कौन से आयन प्रोड्यूस करता है? मेटल प्रोड्यूस करता है कैटायंस, राइट? And we know that cations always migrates towards the cathode. One principle that we have learned is C to C and A to A. So since cations migrate, discharge and deposit, 3 steps. Therefore, if we want to coat a metal on an article, obviously the article has to be made the cathode. Then the second, whatever metal, जिस भी मेटल को आप चाहते हैं कि इसकी कोटिंग आपके आर्टिकल या ऑब्जेक्ट पर हो, that metal must be taken in its pure state, and this pure metal has to be made your anode. Why anode? Because your metal, whatever you are using as an anode, is going to act as an active electrode. जब active electrode होगा तो वो अपने खुद के cations produce करेगा, and again cations will move towards the cathode, and obviously they'll be deposited at the article. Then the third is whatever electrolyte, जो भी हम electrolyte यहाँ पे use करेंगे aqueous state में, that must have the ions of the metal. जिस भी metal को आप इस आर्टिकल के ऊपर डिपॉजिट करना चाहते हैं, आपका इलेक्ट्रोलाइट के अंदर ऑलरेडी उस मेटल के आयंस प्रेजेंट होने चाहिए. फॉर एग्जाम्पल, अगर आप निकल या सिल्वर को इलेक्ट्रोप्लेट करना चाह रहे हैं और मान लीजिए आपने जो इलेक्ट्रोलाइट चूज किया, सपोज वो एक्वस सोडियम क्लोराइड ले लिया, तो सोडियम क्लोराइड में निकल प्रेजेंट ही नहीं है. जब निकल है ही नहीं तो आपका माइग्रेशन एंड डिस्चार्ज एंड डिपोजिशन ऑफ द योर डिजायर्ड आयंस नहीं होगा. दैट इज वाई इलेक्ट्रोलाइट हमें कौन सा चूज करना है, जिसके अंदर उस मेटल के आयंस हो दैट वी वांट टू डिपॉजिट ऑन द आर्टिकल. Then fourth, a low current for a longer period of time must be there. Otherwise, if we take a higher current for a shorter period of time, then a thick and a not non-uniform layer of metal will be obtained at the article, which will defeat the whole purpose. And then very important point, the current used must be direct current, that should be DC, and it should not be AC. So direct current has to be used. Now let us take certain examples of electroplating in which we are going to see that how all these conditions are fulfilled. So let us take the first example of the electroplating with silver. So with silver, we are going to take the, let us have the article as spoon. कोई एक स्पून को हम इमेजिन करते हैं that we are going to electroplate it with silver. So obviously it is an article to be electroplated. So we are going to make the cathode as spoon. अब यहाँ एक कंफ्यूजन नहीं आना चाहिए कि कैथोड को या स्पून को कैथोड कैसे बनाएंगे. सिंपल है, आपका इलेक्ट्रोलिटिक सेल है, ठीक है. इस इलेक्ट्रोलिटिक सेल में एक तरफ स्पून लगाएंगे, ठीक, और एक तरफ वो मेटल होगा जिसकी कोटिंग आप उस स्पून के ऊपर करना चाह रहे हैं, ठीक है. सिंपली अटैच, बिकॉज स्पून इज टू बी मेड द कैथोड, तो यू विल अटैच it to the negative terminal, so it will become your cathode, and attach the pure metal of which you are trying to have a coating on the spoon, attach it to the anode and that will become anode. तो इसमें हमें कुछ सच नहीं करना है, सिंपल जो भी आर्टिकल है आप उसको अकॉर्डिंगली अपने कैथोड के साथ अटैच करो एंड दैट विल नेगेटिव टर्मिनल से अटैच करो एंड इट विल बिकम योर कैथोड. Alright, so now let's have a look at what is the anode. So spoon is your cathode and anode is your pure silver स्ट्रिप ले सकते हैं या एक प्योर सिल्वर बार ले सकते हैं. ठीक है, तो आपका एनोड हो गया प्योर सिल्वर स्ट्रिप, कैथोड हो गया स्पून. अब इस पूरे में इलेक्ट्रोलाइट कौन सा लेंगे? इलेक्ट्रोलाइट जो हम इसमें यूज करेंगे दैट इज गोइंग टू बी सोडियम अर्जेंटो साइनाइड, राइट, a solution of sodium argento cyanide, or we can also have potassium argento cyanide, either one of these are the complex salts. These are not your normal salts, these are your complex salts. Sodium argento cyanide and potassium argento cyanide, we are going to use their solution as the electrolyte for the electroplating of an article with a silver. Fine. Now let's see what will happen now. Let's have a look at the reaction occurring at the cathode. Cathode का क्या था हमारा? Cathode is spoon, right? So silver, the silver cations, right? The silver cations will migrate, will discharge. How will they discharge? By the gain of one electron, right? And then they will deposit in the neutral state, which is silver. So silver is then deposited on spoon, correct? Then comes what happens at anode. Anode क्या है? Anode is a pure silver strip. What is the point to remember here is that since it's a silver strip, so the electrode here is active. Silver is an active electrode. What is an active electrode? Active electrode is the one that takes part in the chemical reaction. How does it take part in the chemical reaction? By producing its own cations. So it is going to produce silver minus one electron and it will give you Ag positive. Right? So see what is happening. कैथोड जो हमने स्पून को जहां पर हमने कैथोड की तरह यूज किया, ठीक है, तो क्या हुआ? स्पून के ऊपर सिल्वर डिपॉजिट हुआ बिकॉज ऑल द सिल्वर आयंस दे वर सिंस cations they migrate towards the cathode and cathode was spoon, so they got deposited there, and anode was an active electrode, so it produced its own silver cations which again migrated towards the cathode and got deposited on the spoon. What will you observe in this? After some time the spoon will have a coating of silver on it, and what will you observe at anode? The anode, that is the pure silver strip, will gradually lose its mass. It will become thinner. This will become thinner. Why? Because in the process it is gradually losing its ions, and hence the active electrode, which is anode of pure silver, will become thin. So this is all about the electroplating an article with the silver. Now let us take another example of electroplating, but this time with nickel. Let us have it with nickel this time. So in nickel, the electrolyte that we are using is nickel sulfate solution. Alright, this is nickel sulfate solution that we will be using, and let the article be let us change the article to key. Let it be key. Alright, so article is key, so that will be a cathode, right? And what will be our anode? Since we are trying to electroplate nickel, so we will have nickel in its pure state. We can have a nickel bar. एक छोटा सा निकल का बार we can use as the anode. Aqueous nickel sulfate. Again, in this nickel sulfate, in order to increase the conductivity, we will again add some dilute sulfuric acid to it. So here the total number of ions that will be present are going to be nickel, then sulfate, then we will have H positive, OH negative. Since it's solution means water. Okay, solution means water. So H positive and OH negative. And from H2SO4 again we will have H positive and sulfate ions. The reason is the same. We are adding dilute sulfuric acid to this solution simply to increase the number of ions that will help us in increasing the conductivity of the ions. So out of all these ions, the ion that will migrate, discharge and deposit at cathode, which in this case is a key, is going to be nickel. So what will we have the reaction at cathode is nickel will migrate, discharge. How will it discharge? By gaining 2 electrons and then producing nickel. And then this nickel will deposit at this key, right? And then what will happen at the anode? Since anode is again the active electrode, anode being nickel. Nickel is again an active electrode, so no anion will be deposited. On the contrary, it will produce its own ions. How? The nickel will produce its own ion by the loss of 2 electrons, right? And these are the cations which are produced. These cations then migrate towards the cathode and will be discharged and deposited. That is how the whole electroplating of nickel is done. Now again the question, why this electroplating of nickel is done? The reason being that this nickel is going to give a better look to the article, and number 2, it will also protect the article from the corrosion. After this, a very important point has to be kept in mind. The thickness of the metal that we are trying to electroplate will depend upon the duration of the time for which the current is passed through the electrolyte. Longer the period of time, the thicker is the coating done on the article. However, we need to keep in mind that this time duration must have a low current in order to have a uniform coating on the article. Now before I conclude, let us have a quick recap of whatever we have done today. The first thing that we have done is electroplating. Electroplating with silver. And in this silver, the electrolyte that we are using is sodium argentocyanide and potassium argentocyanide in the aqueous state. The reactions at cathode. What is cathode here? The article. And the reaction is silver ions, which is a cation, it is going to migrate, discharge and deposit. What will be the reaction at anode, which is going to be a pure silver strip and is going to be an active electrode. The reaction is going to be the production of the silver cations, right? Here one question arises, why the sodium argentocyanide and potassium argentocyanide, such complex salts are used and not a simple salt like silver nitrate has been used? Why silver nitrate is not used? It is so because the silver nitrate shows a quick process of dissociation. It dissociates very quickly. So as a result, the deposition of silver ions on the article to be electroplated is also very fast, and as a result the article do not get a uniform and a smooth layer. Therefore silver nitrate is not preferred. Instead sodium and potassium argentocyanides are preferred. So this is regarding the silver. Now let us change it to nickel. If instead of silver the nickel is to be used for electroplating, then the electrolyte that we are using here is aqueous nickel sulfate, and obviously the article is going to be at the cathode, and here the cathode reaction is going to be the same, that is cations to cathode. So nickel cations will migrate towards the cathode and nickel will be coated at the article. And what will happen at anode? Since here the anode is pure nickel, which is again is active, so here again nickel will produce nickel cations, which will in turn migrate towards the cathode and will be deposited there at the article after getting discharged. Hope this is clear to you all. That's all for the day. Thank you.